Hello everybody, I'm Nick and welcome to another episode of Code Cope, the series where I go over questionable advice given in places like LinkedIn, Twitter or blogs, and I try to explain why it's wrong and turn it into good advice. In today's video, I have a piece of advice that looks good on surface level, and it's actually from a pretty good content creator as well. Of course, as always, it's anonymized, but I want to explain why it is wrong and how you should think when you see such advice to come to the conclusion that you should come on your own and not rely on someone like me hoping to make a video on it. Because if you just see this post on LinkedIn, you're gonna say, okay, that's what I should use. I should use this thing from now on and move on with my life, which if you do, you actually harm your code and your performance, not improve it. And what am I talking about? Well, we have this post over here. Use the find method instead of FirstOrDefault in the list of type T. Many things here, we're gonna demystify everything, but the main advice, as you can see with a big red cross here, is when you have a list, and in this case it's a list of integers, do not use FirstOrDefault if you're trying to match something with a predicate. Instead, use the method find. Now, one thing to mention, detach the idea of find in anti-framework out of this, because that is a different thing. EF works differently with this method. We're talking about list of a type, in this case it's an integer, and FirstOrDefault of a type. Don't think of how this translates into a SQL query. That is different. And by the way, singular default is not mentioned in this because singular default is not checking just for the first occurrence like these two methods do, but it also checks that there is no other duplicate in that collection, and if there is, of course, it throws an exception. And as we can see, we have performance over here where the FirstOrDefault is twice as slow as find. So on surface level, it looks very good. And then we have some memory allocated 40 bytes. Now, when I first saw this, I thought, well, I think these two are very similarly implemented behind the scenes, but I hadn't checked it before. But I also thought that, hey, how is this on microseconds level if the collection is only 5 items? So this tells me that this code over here and what run for the benchmarks is different, and that made me investigate, as well as the person who sent me this post on LinkedIn. And by the way, if you see posts like this and you want me to make a video on them, send them to me on LinkedIn. Now, I want to give all the context that the person provided, so I'm going to go to the text they provided as well for this post, and it's this: find versus FirstOrDefault. When you use list of T, you should use the find method instead of the FirstOrDefault. The find method is generally faster than FirstOrDefault because find is specifically designed for list of T. That is true. Find is not a link method. It is just specific to the list and optimized for this collection type. We'll see about that. It directly iterates over the list and returns the first element that matches the predicate. The FirstOrDefault is more general method that works with an enumerable, which can make it slightly slower due to enumerator overhead. This all conceptually makes sense, but I want to show you the code and see exactly what might be going on. So like that person explained, let's have a collection of numbers. So I'm just going to do the same thing. Now, when people use examples like this, in general, I prefer if they have benchmarks that match an item in the middle of the collection. That's because you get a better idea of how the code performs. If you match the first, everything will be very, very fast. If you match the last, then everything will be very, very slow. So we're going to match 3 here. And what we can do, as the person showed, is we can have test.find. That's the good method, remember. We want to use find. And we can have the bad FirstOrDefault async, which I'm sure many people are using. And by the way, both of these return a nullable type over here. So there's no behavioral changes. Now, this will both work. And if we look at find, we're going to see that it is in fact a method on list here. And all we have is a predicate coming in, which is pretty weird because this is an old method actually. Predicates are not really used anymore. You'd have a function of type T that returns a Boolean instead, which is practically the same thing. And then as we can see here, we have a for loop, and then we run the predicate and we match the item based on that index. And if we find it, we return. If not, we return default. So that's the nullability aspect. Now, I do want to point out here that because this is a list of integers, not a list of nullable integers, this will actually return 0, the default value of a non-nullable integer, not null. This is just a detail I wanted to mention. Then if we go to the FirstOrDefault, as you're going to see over here, we have the try get first. So the predicate is actually a function of tSource with Boolean, a more modern version. And then if we go to the get first or try get first, we have a couple of checks here for the predicate and the source, and then a for each loop on the source. Same predicate idea, we run it on the element, and then did we find it? We mark it as true, and then we return the element, otherwise false, and return default. So these two look very, very similar on a surface level. The only difference seems to be that this is a for each loop, not a for loop, and that we have this Boolean here as well. Now, what I want to do is I want to add some benchmarks. So we're going to go ahead and create the class, and we're going to track some memory because we're going to see how memory works here too. Now, I'm going to just add a list of raw numbers. And what I'll do is I'll say that these are from 1 to 1,000, and I'm going to turn them into a list. So this will contain from 1 all the way to 1,000. What I want to match here is the number 500, just something in the middle. So here are my two methods, find raw and FirstOrDefault raw. So what I want to do very quickly is just go ahead and run these benchmarks and see how they perform. So let's add this, turn this into release, run it, and let's see what we get back and if we can actually match what that passage showed. Now, this is all based on list methods like we saw already, the find method, and also the link method. And you would know all about that and how to use it effectively if you had taken the From Zero to Hero Link a .NET course that we have on DomeTrain. In fact, this course and 40 others are 30% off until the end of September if you use code BTS30. So I'm going to put a link in the description. Check those out. We have everything from clean architecture, modular monoliths, REST APIs, so many more. Do not miss this opportunity. And let's see how this benchmark performed. So results are back. And as you can see, we're very close. Find raw is 323 nanoseconds, so nowhere near what this person showed, but still almost twice as fast as the FirstOrDefault, and we do in fact see that memory. Now, why did I say raw here? I said raw here because when you see posts like this that show list of a value type, never trust them unless they also show you the reference type, because value types and reference types work differently and perform differently, and they can allocate differently, and they can produce different results. So what I want to do is I'm going to add in here a public record called int wrapper. So a class effectively wrapping an integer, and I'm going to add the wrapped numbers now. It's going to be the exact same as here. So there we go, from 1 all the way to 1,000, and we're going to match the center. So let's go ahead and add those two. Not much changes other than the fact that this now is an int wrapper. It is a reference type. And let's see now how the code changes and how the performance changes if we have a reference type into a list. All right, so results are back, and let's see what we have here. So same results with the raw, but find wrap performs the same as find raw, so find on a value type, but FirstOrDefault wrapped is almost 7 times slower than the find version. So it seems that it's not just twice as fast, it can be 7 times as fast on reference types, and with more complex objects, this can increase. So this reinforces that you should use the find method instead of the FirstOrDefault to achieve the exact same thing on lists. Or is it? Well, out of curiosity, I want to show you how SingleOrDefault will also perform in this scenario before I blow your mind. So I'm just going to add the SingleOrDefault wrapped version over here. Remember, this should be the lowest performing one because it has to go through the entire collection first. And that's because if you have a duplicate, SingleOrDefault throws an exception. And I'm going to do the same for the raw over here. So let's just run this again and see what's the big picture. Okay, so let's see where we stand now. So as you can see, SingleOrDefault is 3 times slower than FirstOrDefault and quite a few more than find raw on the value types. And as you'd expect, twice as slow than FirstOrDefault on the reference type because it has to go twice the length. So this all makes sense. So done deal, right? This is good advice. It might be a bit inaccurate in the numbers over here, but overall pretty good. Well, I don't think so. Why do I say that? Well, I say that because I've been using .NET 9 for a very long time now. Even in production, DomeTrain is running with .NET 9 previews and RCs now. And we do a lot of analysis on students, watch time, authors, and so on. And something we noticed is the following. I'm going to go ahead and I'm going to turn this project into a .NET 9 project. And of course, latest C#. I don't think I have to change it actually manually. It auto changes, as you can see. So all I'm going to do is change the .NET version. And I'm going to run the exact same code, including the single or default. So find, first or default, and single or default. And let's see what happens just by increasing the .NET version. All right, so results are now back with .NET 9. That's the only change. And as you can see, no memory allocated for any of those methods. First or default is 3 times as fast as find in both the value types and the reference types. And now value types and reference types perform exactly the same, just by changing the .NET version. So here's my advice. If you're using Link right now, it is extremely likely that Microsoft will optimize it. Do not try to use type-specific methods, especially very old ones like find, unless you know exactly what you're doing and you have a very good reason to do that. Because Microsoft will optimize Link in every release because they know how much it is used. In fact, let's see how they did this. So if I go over here and I go into the first or default, in fact, let's go into the find method first. The find method was untouched, nothing changed. But the first or default, if I go here and I go to get first, you'll now see that we don't just have this loop for each, we will also try to get the span. Yes, it always spans, it only spans, of course. And if it can get the span, it's going to iterate the span and do it there because that is going to be the most optimal way to do this. Otherwise, it's going to fall back to the previous method. And that's going to be exactly the same for single or default. So the same logic is used. If we go try get single, it's going to try to get the span, it's going to try to do its magic over here and give you the best possible performance without having to go through the iterator and have to while move next and all that. And how will try get span work? Well, if we go in here, you're going to see that it's trying to see if the type of the source of that collection is actually an array. And if it is, it's going to use an unsave as, and it's going to then get that span out and return it and iterate on that. Otherwise, it's trying to see if it's a list. So list specifically has an optimization. And if it does, it's going to use collection Marcel.as span, unsave.as, always spans, and then return it and iterate on that. And that's why you should be using first or default for this use case, or single or default, depending on your use case. But don't use the find method. Maybe they're going to optimize that in the future. I can't see why they didn't optimize it here, because they know that everything here is backed by an array. So why don't you iterate on the span of the array? I might be missing something. I'm sure Stephen Tobe has a reason to not do this. But what you should know is that just use first or default and you're covered. But now I want to know from you, what do you think about all this? And which less known collection method are you using? Leave a comment down below, let me know. Well, that's all I had for you for this video. Thank you very much for watching. And as always, keep coding.